Hi, this is Kevin Trainer, and I'd like to welcome you to part 3 of my tutorial on the coding assignment for Severance Chapter 14. This corresponds to its exercise 3 in the coding assignment. So if you haven't played the previous videos or done the previous exercises, I suggest that you do that before you play this and do this. So what are we doing in part 3? In part 3, we're creating a more evolved version of the state class that has uh, error checking in it. It prevents you from setting initial values that are not sensible. Okay? One could use this code in order to detect dirty data. Okay? And we get to see some more features. Okay, so what part of the cheat sheet are we going to be using? Well, we've used pretty much the whole cheat sheet, but we never did number 9. Okay, so number 9 says if and only if your class requires special getter setter code for instance variables, then add implicit getter setter code for only those instance of variables for which it is required using the property notation. So that's what we're going to do. We're going to have a new version of this code. Well, let's get a look at this. We're not going to add a whole lot of code, but we're going to add something we haven't seen before. So let's go to the practice tutorial, and let's copy this my evolved states. Okay, so this is what we're using in the tutorial. You'll be creating a different class in your exercise 3. Okay, and then I'm gonna take it over to my actual tutorial and I'm gonna paste it in. Okay, and let me get this down here. I'm gonna close all these for now because they're getting me confused. I'm gonna paste in this my evolved states and paste it in, and it opens up. Okay, and this is very similar to my basic states. Okay, except it has extra code. So where is the extra code? Well, we have this implicit getter setter code that is down in here. Okay, so even though we add it at this point, it typically gets placed between the code for the constructor, which is first, and the implementation of the string method, which was originally second, but now we've added this extra code in here. And what does this extra code say? Well, it says for the 3 instance variables, state name, land area in square miles, and water area in square miles, that each of those has some potentially error values that we want to check and raise an exception to stop the program processing. Well, that's kind of drastic, but we know that code that uses this class could wrap the constructor, the call to the constructor, in a try except block, and it could actually catch the exception that we raise. We don't have to really blow up the actual program, although that's what we're going to do here. And what's being checked? Well, we're going to check state name to make sure that it's not blank. not the empty string. Okay. How do we do that? Well, we do that in these two methods right here. There's a getter method and a setter method. And then how do we check for the land area being greater than 0? Well, we do that in this pair, which is the pair for land area in square miles. And then how do we check for water area in square miles? Uh, Not having a silly value, less than 0. We've decided that less than 0 is the, I guess, is the erroneous value. Um, well, we do these two right here. Okay, well, do we add any unit tests? Yep, we do. We add a bunch of unit tests down here. So you remember the basic version, I think, had 4 test cases. And we add a test case for we test passing the empty string to the setter for state name. And then we have another test. We test passing uh, 0 to the water area in square miles. I should probably pass on -1. Let's do that. Test passing -1 to the water area in square miles. Okay. So the expected water area in square miles would be uh, -1. I think that's what we want there actually, because oh, no, that's, I don't want to change that. We said that they both could not be 0. So I don't want to change that code. My bad. Okay. Okay, so that code's fine. And that's it. So uh, we added some error checking code for each of our 3 instance variables, and we added, in this case, a test code for each. So we got 3 more test cases. Could you check for more than one kind of error? Yeah, you can. You might check for low values or high values or just any nonsensical value. That would mean that you would need more than one test case. Okay, so it's possible for this implicit setter code that we're creating here, it's possible for it to test for more than one value. And if that's the case, well, then you're going to have to test for more than one value in your test cases too. You'll need a test case for every error value that you want to catch. Here it's been 1 to 1. Okay, so how are we going to do this? Let's look at this code. Let's look at the code that we added, and let's not try to understand it all at once. Okay, let's just take the name code, and let's take the other code that we added and put those into comments. And then let's just take the test for the state name, which is test 5, and let's put that into comments. Okay, so we want test 5. We don't want things starting with test 6. Okay, and let's just run the test. Okay, so let's run the test. Run my evolved states. And we just went down to test case 5 and it passed. So, well, it passed the code. So let's look at the code and the test code. Okay. So what's the code itself? The code itself is a pretty fancy way to test for error values. It turns out that in Python, the the currently accepted way to test to protect your instance variables is to use these implicit getters and setters. So we never create in Python, we never create a method called get uh, instance variable name, or a method called set instance variable name, um, because um, what we want to do is if we add this functionality, we want the original client code, which of course was not calling getters and setters. We don't want that to break. So we want the original client code to still look like it's calling. It's not calling methods, but it's accessing the fields. So what does this code? Well, what this code does is it wraps this method here on top, the top one, it wraps it around every time that we try to read the instance variable field. It actually calls this getter code under the covers. Okay? And we don't have any fancy getter code. It just does, it just gets the code. And then uh, when we try to set the value of the field, okay, it looks in our client code like we're simply accessing the field, but under the covers, now in this more evolved version, it calls this implicit setter code, and there's a check in here. For instance, if the state name is equal to the empty string, and if it is, it raises an error. Okay, so it, because we're not catching the error in the client code, typically we're going to get a runtime exception. Okay, so at this point we just want to test the code by having it blow up. Okay. The other thing that we do here is we begin to have shadow values for the instance of variables. So what we do is we have a dundered version of the state name. Does that mean that it can't be seen from the outside? No, it doesn't, but it warns people that they should not be accessing this value directly. Okay? Um, this semi magical implicit getter code is going to uh, get the hidden state name, and it's going to return it as the value of the instance variable. Okay. Likewise, the setter is going to store uh, the name that is passed in into this hidden value of state name. Okay, so as soon as we add these implicit getters and setters, we get these shadow variables that are dundered. Okay, now what's really interesting is that all the client code never ever sees these dundered hidden values. All the client code sees is the value of the instance variable. So that, for instance, all the true client code uses just plain old access to fields dot field name. Okay, and that's what the constructor does. Okay. Uh, Likewise, in our unit tests, we're going to have code that looks like this. That's why the unit tests that we've already written, 1 through 4, are going to run just fine. We're not going to break them. Okay. All right. So these. So what are these lines? This at property and this at state name setter. Well, at property is a way to tell the Python interpreter that we're going to have an implicit getter for the state name property. And then the second one says we're going to have an implicit setter for the state name property in which we can do error checking. And it's going to provide all the infrastructure to make that happen kind of invisibly to us. Not totally invisibly, because when we do the unit test and we pass it an empty string for the state name, this code is going to catch it, and we're going to be able to confirm that in our test. Now, why do we add these getters if they don't really do anything? I mean, they're not changing the value. Well, it turns out that you can't create one of these implicit setters unless it's paired with an implicit getter. Okay, so we have the getters because we need them to have the setters. Okay, you can't have an implicit setter without the implicit getter. So we have these very rote, dummy-ish kind of implicit getters that are not very difficult to code and not very difficult to test, simply because that allows us to create these implicit setters. Okay, so let's go down. So let's just take what we have so far. Okay, and so we've got the getter and setter for state name. Let's try to test that new capability for state name. Where's that? Well, it's in test code 5. It's in test case 5. So let's run this again, and we'll see that to test case 5 actually passes. Now let's look at test case 5, because this test case code is a little more sophisticated than we've had before. Okay, how's it more sophisticated? Well, 2 or 3 different ways. One is an actual passing test is one where it caught the error. Okay, so that's one where the code raised an exception. So you have to have this try except finally block in your test code in order to make sure that the code actually blew up. So oddly enough, you begin the test the same old way. You code in the expected values, but what you do is you assume, instead of assuming as we have in the past, that we assume that the test case passed, the convention here is we assume that it failed. Okay? Because if in fact it doesn't blow up and we don't catch it, it does fail. If we don't catch the error, it's failed. So, and then in the try catch block, okay, if in fact when we put the constructor into the try block, that's the same constructor that we had before. In the accept a block, we catch an attribute error, okay, and we're expecting that the message from the attribute error will be the state name attribute must be populated with non-empty string value. Okay, if we catch that error, well, then we passed. So this error checking code, writing a test case for error checking code, is a little mind bending. Okay, because to pass the test, you have to blow up the code and catch it. Okay, so the only thing that passes is when we actually detected the error and we caught it. And this finally means we're always going to print the result. That's what printed passed. Okay? So it's a little mind bending. The idea that the client code isn't actually explicitly calling the getter and the setter, that they get implicitly called just when we access the fields in the same old Pythonic way, that's a little mind bending. Okay. But what's nice is that this did not break any of these first four test cases. Okay, the first four test cases were all testing name. Okay, and we didn't have to change any of these test cases. They're all client code, right? We didn't have to change any of them, and they're not broken. Okay, they're not broken because the getter and setter that we added are implicit. We don't change. We still access fields the same way. We still say S1 dot land area in square miles. We still say S1 dot state name. Okay, so we never in modern Python, which is Python 3 with good practices, we never call explicit getter or setter methods like they do in more formal, older style program object-oriented programming languages like Java and C++. It's all if we're going to add this feature like we're doing now, uh, we add it using these property decorators, and they become implicit. Okay, so old code doesn't break. All right, so we do the same thing. We're going to do the same thing for land area in square miles. So let's add that, toggle that code on. Okay. And the other thing that we have to do with these things, um, well, no, I don't want to talk about that now. So land area in square miles, and then let's go down and find the test code. That's test case 6. Test passing 0 to land area in square miles setter. Let's toggle that off. Okay. And let's run our test again, and we should run. And now we passed test case 6. And then finally, the last instance of variable that we want to do some air checking on is this water area in square miles. Okay, so again, we code the implicit getter with this property decorator, and the implicit setter with this decorator that says water area in square miles dot setter. Okay, and then we add the test case for test passing a -1 to the water area in square miles setter. I don't think we want to do that. I think we're actually passing a 0. 0. So we're really doing that. Not really a -1. Okay, so at one point I was passing a -1s. So comments, you have to remember to maintain them. Okay, so this should pass 2. So let's run this one more time. And it passed all the way through test case 7. So the real power of this modern approach to adding getter setter code to control values and instance variables. Uh, uh, the really cool thing is that you can still have a test case of like the first 4 that don't really depend on the simplicit getter setter code, and they still work just the way they were. Okay, those all still pass. And then the the three test cases that we added to catch the error conditions, they pass too. So even though we've added this extra code, this implicit getter and setter code, um, uh, uh, we don't have to change the old client code. It still passes the unit tests, but we can test the new features. They work too. So this is a very Pythonic way to add the controlling values in the setters, but we do it implicitly, never explicitly. So we're done. That is number 3.